Hello everyone, thank you so much for joining this session on repair. So my name's Alicia Story and I will be your online host for this session. If you haven't seen me already, then I am the founder of A Design Story and I'm also the UK chapter co-lead of Climate Designers UK. So much of design for planet is about repair. So that's exactly what we're going to be talking about today. So here we have a practical how-to session with Milo and Dean from Batch.Works on how to design for repair. Batch.Works is an on-demand 3D printing manufacturing company with circular economy principles. And I'll hand you over to Milo first and then Dean to introduce themselves. Over to you.
Hello, everyone. My name is Milo Mcloughlin-Greening. I am a co-founder and the head of R&D at Batch.Works. I'll hand you over to Dean.
And I'm Dean Pankhurst. I'm the design coordinator at Batch.Works. So we have an embedded design kind of consultancy service that we run to get fantastic, beautiful, sustainable products made in our own factories.
Cool. So, obviously, this session is all about design for repair. We're going to be talking to you about our approach to that. So initially, a little introduction to Batch.Works and how we work. And then we're going to be moving on to a specific case study project, which you can see it there on this slide, where we're going to be sort of digging into the design for repair principles that we take on board in-house, and then sort of unpicking them a little bit more in depth as we go through. So first thing to sort of cover is Batch.Works itself. So at Batch.Works, our mission is to change the way things are made. We're creating practical, viable, circular manufacturing practices, through developing smart technology and sustainable production methods. Our vision is to be the leading supplier of sustainable production and manufacturing capabilities to brands and designers around the world. So what does that actually mean? At the moment, Batch.Works is a growing team of around 20 designers and engineers that is really looking at how we can utilize and leverage existing digital production technology, so essentially 3D printing, to bring ideas about the circular economy and distributed manufacturing into a reality. We have two current manufacturing sites. We have a factory in London and a factory in the Netherlands, where we are already working with a range of global clients to develop products which are utilizing recycled materials and sustainable practices and this digital technology to realize these ideas about circularity. At the same time, we are really focused on research and developing overcoming the hurdles that are apparent for unlocking these theoretical ideas about circularity, distributed manufacture, repair. So we have a team of around 10 engineers working on developing AI technology to allow this sort of systemic approach to making things to become a reality. So on this diagram, on this slide, you can see a sort of simple diagram of how that might look. So we have this sort of distributed cloud-based platform of multiple manufacturing sites spread around the globe. These are all connected through data and smart production technology, enabling us to produce things when they're needed and where they're needed. So having a really local approach to production, which is only enabled through this digital approach to making things. That's quite unique to the way in which we traditionally produce parts. So specifically the benefits of making things in this way. Digital production means there's no tooling. So traditionally, where you might have a part which is molded, the tool itself might cost hundreds of thousands of pounds, and you might need to create a minimum order of, I don't know, hundreds of thousands of units, which then would have to be sent all the way around the globe, creating huge amounts of embedded CO2. With digital production, you don't need to do that. So you don't need to have this tool. You can make things in one-offs. You can make things to order, which means that you never have to create waste, you never have to create parts that go unused, and you never end up creating these huge stockpiles of unused items. Through the specific production technology we're using FDM 3D printing, which is essentially the most basic form of 3D printing. This is sort of the most crude way to produce things using this technology, but it also is the only way that really allows us to utilize recycled materials and experimental materials. So that's really key to our process, because this is really core to the way in which Batch.Works is growing and what we're all about. Parts can be made on demand. Another huge benefit of this digital way of making things is that we can start to think about the production of hardware in a similar way that you might think about software development. So you can create lots of versions and lots of different color variations of parts without actually ever creating any waste, because you only ever make the parts that are ordered or the parts that are sold. So it's really about using this technology to reduce waste. We can have short supply chains by having this distributed network of production, and use recycled material throughout. So then we can move on to our case study project. So this presentation is all about design for repair, and I thought it'd be really good to talk to you about a collaboration, specifically because this Design for Planet Festival, the key theme is collaboration. This year, or actually maybe starting about a year ago, Batch.Works began a collaboration with a close neighbour. So our studio is based above a bus station in East London, the most East London thing you can ever imagine. But we're in this really big open space, which is shared by lots of different creative studios doing all sorts of different things. And our neighbor in our space is an industrial design studio called Morrama. You might have heard of them. Joe, the founder, is talking at the festival, so make sure you look out for that. So we've been next to each other for the last 2 years, and we've been manufacturing things out of sustainable material. They've been designing this really beautiful, well-designed industrial products, and we've just been really hunting for a way in which we could work together. So there's been ideas being kicked back and forth for, I don't know, literally for the last 3 years about the sort of thing that we might actually pursue. In collaboration with Morrama, we've also been thinking about, if we want to design an object for repair, how are we going to communicate that? So we've worked with a graphic design studio called Studio Don on all of the branding for the product that we're about to present. So I can now introduce to you Kibu.
So we were thinking, what could we make? What could we make that would serve as a kind of focal point for all of these theories, these kind of wide-ranging ideas around sustainability and how to make sustainability real and scalable, and package that into a product which is simple and kind of everyday and tells a story in a really tangible way. And headphones are a really great way to do this. And particularly what we were focusing on is children's headphones. Now, these are really technologically simple. They use kind of standard analog components, cables. The idea behind it is to create something which is readable, disassemblable, kind of modular and colorful and playful. And we think that this embodies everything that we want to express around, this is our manifesto boiled down to a product, basically. With this whole kind of like story, we wanted to start with understanding what our principles are for sustainability, and relevant to this talk is repair. You can't have a sustainable product without thinking about its repairability and the idea that it has a life which is extended as much as possible. When thinking about this, we were thinking about materiality. So much of what we do as a company is around the things that we make stuff out of. Everything that we make at Batch.Works is from bio-based materials like PLA, or from recycled materials, and everything that we use is recyclable afterwards. So everything needs to be this product had to be made from recycled materials. It had to be sustainable. It had to be modular. Modularity allows us to make multiple products that share parts. It allows upgradability. It allows people to repair items easily themselves if things get broken or lost. It's really important. Also, standard fittings. This is quite easy to do on a pair of headphones because that 3.5mm jack is really standard across lots of different headphone products. It's really easy to make circuit boards that use components, that use parts that are really, really easy to get hold of, and that's really important. So again, this is a really appropriate product to explore this with. We didn't want to use any adhesives. So many products, consumer electronic products use so much glue lately in this kind of like search for thinness and for kind of consolidating, but using adhesives makes it really difficult to recycle because you have to peel all of that away, and it's really difficult to disassemble and reassemble things. So we innovate in this space in order to make snap fit parts that click together really easily and then hold themselves really firmly together, and at the point that you want to disassemble, you can use force to pull them apart. It's a really easy way to construct and deconstruct. We didn't want to use special tools. So again, using these snap fit mechanisms, it allows us to do away with screws. Again, making parts that are easy to kind of make and unmake. And the availability of spare parts is something that is really exciting for us because we're in this amazing position being both a factory and a kind of design studio and a publisher of products. We can utilize our distributed local factories to ship maybe just one part of the product if it gets lost or broken. It means that the customer doesn't have to throw their things away. It can just be like replaced or augmented, and that's really important for us. And because we're agile and able to shift around, it's really quick for us to do that as well. The storytelling about this product is also super, super important, and having clear instructions about how the product is made, what it's made from, and how to do this assembly and disassembly is really, really important. We don't want to hide anything. We want everything to be really clear, well communicated, and particularly for children to understand. I'll talk about this later. Also, the kind of communication physically as well. And to be transparent, as I just mentioned, to make sure that the world knows about it, that the customer and the user understands what it's made from, where those materials have come from, and what we do as a company to ensure that we design things so that we utilize these like sustainable supply chains and everything about the product is demystified. Super, super important. So here it is, in a kind of exploded view. What you'll see here is these kind of really graphic shapes, these big components that you can grab onto and click things together, pull them apart. You can see how there's a circuit board on the inside there. What you're seeing here is an expression of a kind of design language that's brought about from using 3D printing. Because we're experts in 3D printing, we know so much about how to use it in a really interesting and exciting way, and we don't shy away from the layers that you get on 3D printing. We don't try and pretend that it's another process like injection molding. So that's why everything has these really chunky layers, and that texture and that feeling is so graphic, and it's so kind of exciting and tactile, especially for a children's product. We really wanted this to be a kind of playful object and something which you want to touch and grab and pull. You know, we don't necessarily want kids to pull it apart all the time, but we want them to hold it, and we want them to feel excited about it. And this is a prototype here that we have. You can see here that it's like it's of a scale that's very like characterful, and these different color combinations are really easy to enable, and we're currently working on refining this even further, and then kind of bringing it all together and launching it really soon. So this is it's a manifesto for what the company is and what design is in this company, and how circular it can be. The packaging as well is a really, it's an important moment to be able to communicate the story to the customer and the user. And that goes through marketing, it goes through the telling of the story of the materiality. And it's really about making people feel like they are using a product that is thinking about it's sitting inside of a structure that's reimagining what manufacturing is, and it's reimagining how we can be consumers in the world, buying stuff, but in a way that maybe like makes us feel a bit less guilty. And the instructions allow you to engage with it on a very like human, tactile level. You feel like you own the product and you know everything about it, and it's like it's part of you. You're able to like pull it apart if you wish. You like you know it, it's yours, you know it.
Okay, so I think a key point about this project is that it is completely self-directed, which has really allowed Batch.Works to lean into developing something where we are able to really push all of our principles about design, particularly design for repair, but also manufacture, remanufacture, circularity. Normally, we are working with clients that have a specific brief or the specific constraints, but because we've been able to run this project as completely self-directed in collaboration with Morrama, we've really been able to take ownership of the whole process and do things how we want to do it. And I think a key point for this is that we really believe that you can't make a sustainable product, or you can't make a repairable product without changing the way in which you make them. I think it's really easy, or not easy, I think it's really possible to design something that can come apart or can be repaired, but it really needs to fall within a system of production. So that's what we're working towards at Batch.Works. So one of the main things that we are able to lean on within this product is that we have control of our own supply chain. So as Batch.Works is the manufacturer, we're able to choose where our materials come from and who we interact with in terms of the product at a component level. This also comes from taking ownership of the product ourselves and there not being a client involved. And as Dean was talking about transparency earlier as one of the key points, this is a really key moment for us to be able to express when we are doing well in terms of sourcing third-party components in our supply chain, but we're also able to be the ones that are transparent about moments where we've had to go for an alternative which maybe isn't as sustainable as we like or isn't the best choice. So, supply chain and having control of that is really key. In terms of design for repair, because we have this agile and on-demand system for manufacture, it means that compared to traditional production where you might need to guesstimate how many spare parts you might have when you're in the design process, we don't need to do that at all. If a part breaks or if we need to send out a replacement to a consumer or a client, we can just make it on site. So we don't ever have to make this guess about the amount of spares that we need. We can be completely agile to the demand as it peaks and troughs. And there's also loads of other benefits about this type of technology. We can release a huge range of color SKUs, but only ever actually print the ones that get ordered. And also we're able to update and refine parts when they're already in the market, because it doesn't cost us anything to make a new tool. We're not investing huge amounts in tooling. Material considerations, Batch.Works, we are really focused on using 100% recycled feedstock. Oh, I think we're running out of time. And all of our material comes from the Netherlands. It is collected from agricultural waste, and then it's turned into our raw material on site in our factory. So it's about 2 meters away from where our production happens. That's where our material is produced. A really key point I definitely want to get in is this idea about supply chains. We're able to make decisions about who we work with in terms of the component level of the parts. With this project, we are collaborating with a company called Jiva Materials, who have a patent on a technology called Soluboard, which is a PCB that can dissolve when it is in super hot water. So even if this part didn't get recycled, the circuit board is made out of biomaterial instead of glass reinforced plastic, GRP, which traditional circuit boards are made out of. But as we are able to collect and take parts back, we're able to even recover and repair parts at a component level. So dissolve the circuit board and take the components back and put them for reuse. At the end of the life of a part or a product, whether that be a specific piece breaks or gets lost by somebody, we can make the decision as to whether we print and send a part back or incentivize the return of those bits and pieces through varying methods. At the moment, we're doing a bit of research for a piece of technology that should come through in the next few years, very early stage, where we've identified a way to embed unique part identification. So like a DNA into every single component that we produce. This is going to be instrumental in the way in which we're able to collect things back and incentivize methods for repair. I've been rushing, but we're onto the last bit. So.
I think this is a really exciting moment. It's an exciting moment for the company. We feel like we're able to author an expression of our values in a product. And because this is targeted at children in such a playful way, we think that we can begin to build on this momentum that young people have around loving sustainability. We need to like encourage this. We need to make sure that we're there to capitalize on this, to bring that kind of passion for making the world a better place, and to meet them with these kind of like system-wide interventions and products that suit those systems that we're building. And this is a way to influence behavior change. It's to build a kind of shift to move manufacturing into a different, better place by creating such a compelling reason to do so. And we really think that this is something that is applicable to so many different products, and the methodologies are so ready to be used in so many different ways, and this is a really amazing moment to do that. We invite you to register your interest. It will be sold. It's coming. We're in the kind of end of the development process for the product, and we're going to be putting something together. So if you feel excited about this and you want to learn more, then please do register your interest and reach out to us in any way with any thoughts about any of these things. And we're really open to answering questions now on this one. Is there anything you wanted to add?
No, I think that's great. Yeah, I think for us, this is a really exciting moment. Like Dean says, we're really trying to draw in all of the principles that we think make our ideas about the future of manufacturing. We're trying to draw them all into one product that we actually have ownership of. And it's really exciting for us, and be really interested to hear people's opinions in the Q&A, but also reach out to us, because we're really open to the way in which we develop as a company. We're really excited about hearing other people's thoughts on these things.
Thank you.
Thanks.
Thank you so much, Milo and Dean. That was really inspiring. It was very, very helpful to see the live case study, and such an amazing testament to collaboration, sustainable collaboration in action. So thank you very much for that. It's also, I think it's really interesting that you've decided to focus on children's headphones as like a testament for sustainability of the future, like growing up in a generation where you, if this was the future product, you repair your headphones rather than buy it for a period of time and then buy a new set. So I think with that kind of angle, it's really beautiful, and how you've thought about it down to every single detail, looking at even the down to repair for the circuit board, for example, as well, like is quite amazing. And the snap fix mechanism is really fascinating as well, because you're right, there are so many glues and different kind of binders often in products and in construction as well. I'm an interior designer, but I think there's so much learning from this case study. So thank you very much for sharing that. So I'll now go over to the audience questions and see what we've got there. So one question we have is, what with the dissolving, the byproducts, are they safe for entering water systems? That's a very specific question, but I don't know if that's something you can advise on.
Yeah, as far as I understand, yes. I think it would be really you should check out Jiva materials. But yes, the answer is yes. It's water soluble and it can go into the water system.
Great, thank you so much. So I have a few more here. Can you share on some of the challenges or obstacles that you encountered during the development of the Kibu project, and how did you address them?
Well, honestly, when you touched on the snap fittings there, since I've been since Batch.Works has grown, I'm less and less involved with the everyday design process as part of the team, and Dean is leading our amazing team of designers. And this project for us is really exciting because it is a move into consumer electronics, which is an area which is complex. It's multi-component and it's multi-part, and we're tapping into a larger supply chain than just making monomaterial products, which is typically what Batch.Works have been doing so far, which is why this is a really exciting step for us. But clipping and holding multiple different materials and parts together is a huge design challenge. And every day that I come into the studio, I am looking over to the designer's desk, and they're constantly dragging people over me. Look at this, look at what we've come up with, because designing for additive manufacture, in particular FDM 3D printing in this way, is a completely new way of thinking about producing parts. Typically, this technology has either been used as a hobbyist tool, so in people's bedrooms, making things that are maybe not so useful, or maybe they're making one-off parts that take a huge amount of time to produce. The design team at Batch.Works are constantly innovating and thinking about ways in which we can make production-ready parts that can be printed in an efficient time, but also have these like crazy clipping and sliding mechanisms, which every day it feels like they're just breaking new ground. And obviously every day is a challenge. So I'd say
a product like this is really an opportunity to explore, and it's an iterative process, and I think it gives us an excuse to develop really innovative ideas. With client work, sometimes you're under restraints with time and money, and you kind of just need to do what they're asking for. But with a self-directed product, you're in a sandbox and you're playing.
You can take it so far. Down to every single detail.
Yeah, exactly. I think, and not everything works, and that's fine. And sometimes you develop something and that can be used on a different product.
Yeah.
But yeah, we're doing everything we can to elevate 3D printing into a beautiful option in terms of manufacturing, and that's part of the mission of changing how manufacturing works globally. It's to establish this as a viable idea in the hearts and minds of everyone in the world, and by creating products that are elegant and beautiful and sustainable and have everything you want, that reinforces the reason why you would do it this way.
I think like over the last few years, this type of 3D printing, FDM printing, is almost its own worst enemy, because if you sort of are slightly involved in this industry, it has this stigma around it of creating low quality parts that have a really low quality finish, and straight away is disregarded as an option for a feasible manufacturing method. But honestly, if you come into our studio or get your hands on one of our products, you'll be able to see that there are many ways to gain a really high quality finish, and it's really about tuning the way in which you design specifically for this technology, rather than trying to squeeze a square peg into a round hole, which is maybe what normally happens with this type of making stuff. Sorry.
Brilliant. Thank you so much. It's so inspiring, and it's incredible to learn more about the operations of how you're kind of the whole concept of it and how it's all come together in this product. It's beautiful. So thank you so much. There are more questions in the chat, but unfortunately we're at time. So I'm not sure if Batch.Works, Milo and Dean, you'd be open to people reaching out beyond with specific questions about Kibu do, and maybe other aspects of the business as well, because yeah, we're at time. But thank you so much for that fantastic session. Very much appreciate it.
Thank you.
Thank you so much.
Thanks.